Since we have so many data values for class 1 and class 2, it would be helpful if we did not have to do this by hand. So what we're going to do is put them in the calculator. Now, yesterday we discussed putting these problems in the calculator, and we'll try to demonstrate that here if we can see it. Can y'all see that?
No. Yeah.
Decently?
No.
All right.
Alright, I'm done.
All right, let's see if we can do it without the light. All right. Now, to put these numbers in the calculator, we're going to follow some simple steps. The first thing that we do, looking at the calculator, is press the Stat button. So I'm going to press the Stat button, and that takes me to a screen that says Edit, Calc, and Test. Now I want to press number 1, press Enter on number 1 of Edit, and that takes me to a list. You can see the list there. Now we want to delete all the values that are currently in list 1, and then input the values of our first list of data here. So just plug those numbers in. You plug it in, 80, enter, 81, enter, and so forth until you have entered all of the numbers. Now, since there are so many numbers, it's easy to leave one out, so you got to be careful. It's a good idea to count the numbers ahead of time to confirm at the end that you've at least inputted the correct number of items. All right, there should be 20 items in this list. All right, so if your screen says at the bottom L1 and 21 in parentheses, that means you've done it correctly because now it's in that 21st spot and the last number is right above that. So to continue this process of finding the summary statistics that we learned about yesterday, we're going to press Stat again. And it takes us to that same screen. We want to go over one place to Calc and press Enter on number 1. Now when we come to the screen, it says one variable stats. Notice the list is L1. You need to be L1. So then we go down to Calculate with the down arrow key. I just use the down arrow key to go down to Calculate. Press Enter. And we see our stats. Now the first stat there is the mean. So let's write down the mean in the blank underneath class 1. Alright, so just have to borrow one. Alright, so our average or X bar or mean, however you want to say it, is 79.4 rounded to the first decimal place. Here. Just drop your bag right there. Alright. So our mean is 79.4. Now if we scroll down, we see that our minimum value, min x, is equal to 70.
Wait, 79 point. Did you round?
I did. Okay, our minimum value is 70. And then our Q1, well, I'm having trouble getting this arranged. Okay, our Q1 is equal to 76.5. Our median is equal to 79.5. Our Q3 is 81.5, and our max X value or max value is 90. Okay, so those are some of the summary statistics that we discussed yesterday. We also talked about how to find the boundaries. We learned that to find the boundaries, we need to know what the IQR is and multiply the IQR by 1.5 to get that special number. So my IQR is the interquartile range. So I'm going to subtract Q3 and Q1. So Q3 minus Q1 would give me 81.5 minus 76.5, and that comes out to be 5, right? Okay. So my IQR is 5. Now to find my special number, I'm going to take the 5 times 1.5, and that's going to give me a special number of 7.5. Okay? Now my 7.5 can be used along with the quartiles to find my boundaries. To find my lower boundary, LB, I'm going to take my Q1 minus the special number. And that gives me 76.5 minus 7.5. And that comes out as 69.5. So 69.5 is my lower boundary. Now, do we have any numbers that are less than 69.5 in this list? No. So we would say there is no lower boundary, LB. Now for my upper boundary, I'm going to take Q3 plus that special number. So that gives me 81.5 plus 7.5, and that comes out to be 89.
How'd you get 7.5?
That's my IQR. That's my special number, determined by 5 times 1.5. The IQR times 1.5. You always use 1.5, as we saw on our worksheet yesterday. 5 times 1.5 is 7.5. So that's my special number. The 5 is the interquartile range, IQR. Q3 minus Q1. All right, so our upper boundary is 89. So do we have any numbers in this list that are greater than 89? 90. Since 90 is greater than 89, 90 is the only outlier of this list. Now, that's kind of odd. It seems like 90 wouldn't be an outlier because it's pretty close to a lot of the other numbers. But that's why you cannot fully officially determine what outliers are until you have found what your boundaries are. So there is one outlier in this list. So these values are a lot of the values that you're going to be asked to find when you're asked to find these statistics. All right, now all of that was a reminder of yesterday. Well, we found a lot of things.
I know, we just found the outlier though.
Well, the outlier is just the last thing. Yep. All right, but yes, you have to do lots of things in order. You have to find all the quartiles, the interquartile range, that special number, just to be able to determine an outlier. So you're exactly right.
It's going to be 69.5 is the lowest.
69.5 is the lower boundary, but there are no numbers lower than that.
Yeah, so it's not.
So there's no lower boundary. If there was, then you would have some lower outliers. Like let's say you had a 68. That would be an outlier. There could be a lot of outliers. It just depends on what the list is.
Yeah, that makes sense.
Okay. Okay, so that's what we did yesterday. A very, very brief version of what we did yesterday. All right. So today we're going to talk about mean absolute deviation. Okay. Today's lesson has to do with mean absolute deviation. Now let's break it down word by word to kind of figure out what we mean here. Now we're going to have a list of data. We're going to be asked to find the mean absolute deviation of that list of data. Mean is your average, right? So we're taking the average of something. Absolute refers to absolute value. Now, absolute value is a distance. Tell me, is a distance ever negative?
No.
So the distance from Ocilla to Tifton is the same as from Tifton to Ocilla. It's not a negative. You never get a negative. It's 18 miles. There and back, same. You say 18. You don't say negative 18. All right? So absolute value is a distance. Officially, absolute value is the distance of a number from 0. So negative 3 is the same distance from 0 as positive 3. So the absolute value of a negative number is always what? Positive. So the absolute value of negative 3 is 3. We use these vertical bars to represent absolute value. So we're going to be dealing with absolute value in this problem. Deviation. Deviation is how the numbers are different. Okay, in this case, deviation means how the numbers are different. So how far apart are they? Okay, that's what the deviation is going to mean. So we've basically broken down what mean absolute deviation means. It says on the worksheet, another way to describe the variability of a set of data is to use its mean absolute deviation. The mean absolute deviation is the average distance between each data value and the mean. So we're going to have this list of data items, okay, and we're going to determine the average distance of each of those items from the mean. And we have to use absolute values since we're dealing with distance. All right, so there is an example here at the bottom of this front page which does everything we're going to do. I'm just going to show you, I think, a little better method that Miss Willis, not Science Miss Willis, Miss Dana Willis, came up with several years ago. I don't know where she found it, but it's really good. So we're going to use her method. So turn the page over and look at number 1. It's a very simple problem. All right, that's actually number 6. All right, number 6. Calculate the mean absolute deviation of the following sets of data. By the way, mean absolute deviation can be abbreviated as MAD. You might be mad that you're in math class. Well, please don't be. All right. Now what we're going to do is we're going to take our list and we're going to write it vertically. And I'm not going to give you a whole long list of numbers. So you'll have enough space to write it vertically. 6, 8, 12, 17, and 17. Now, I like this method because it keeps things in order and it keeps things, it gives you a process to follow every time. Now, again, if you have 100 items in your list, you can't list them vertically. Plus, I would never ask you to do this by hand for 100 items. All right, what we're going to do first is take the average X bar of these numbers. Now, I like to do this little arrow thing here that's like a bracket with an arrow bracket. We're going to find the average. So how do you find average? Add them up, divide by how many there are. So do that now in your calculators. All right, so we've done number 1 from the worksheet from 5-7 practice. We found the range, Q1, median, Q3, and IQR. Now, I want to do this same problem. Just to remind you, I want to do it by hand in case you didn't have a calculator. Now, these are not very long lists, especially this one. There are only 6 items in this list. So notice, to do these things, to find these quartiles and the median, the numbers have to be in order from least to greatest. So I'm going to put these in order. 13, 15, 18, 19, 22, and 25. There are 6 items here. So in order to find my median, you're going to start by finding the median when you're doing it by hand. I have to find the average of the 2 middle numbers. Whoops. The 2 middle ones are 18 and 19. So the average of 18 and 19 is just halfway in between. which would be 18.5. So 18.5 was our median. Put a bar to represent that median. Now to find the lower quartile, Q1, I look at the left side and I find the middle number. Well, it's 15. So Q1 is 15. Put a bar through it. To find Q3, I find the middle number of the upper half, which is 22. And that's Q3. Okay, then I can take my lowest number, my highest number, and find my average, my range, sorry. And then the IQR we learned was the difference between the quartiles, Q3 minus Q1. All right, so that's how you do it by hand if you don't have the calculator handy.